let's talk about the cross product of two factors, especially the idea behind the formula. Why are we using the 3 by 3 determinant of a matrix to find the cross product, and what exactly are we trying to do when we have the cross product? Here we go. First, we are going to consider two factors. Each of them has 3 components. Keep in mind, when we are finding the cross product of two factors, they have to be with 3 components. Imagine we have factor A and factor B. Sometimes it's useful to have another factor that's orthogonal to both of them. That's the idea. Imagine you have the x and y axis. Well, z-axis is orthogonal to both of them, and here you have the right-hand rule. But in general, the idea is that we want another factor called C with 3 components, C1, C2, and C3, such that C is orthogonal to A and C is orthogonal to B. And orthogonal is just a fancier term for perpendicular when you are talking about factors. How do we check it though? When we have 3 components, it's extremely hard to draw pictures. Well, to check if they are orthogonal, we check the dot product. If the dot product of A and C is equal to 0, then we can say they are orthogonal. First, the order of the dot product doesn't matter. Second, the output of a dot product is just a number, so I just have to put on 0 without the arrow. And then we also want B dot C to be 0 as well. Now, the goal is to figure out these components, C1, C2, and C3. That's pretty much the idea of finding the cross product. Here we go. A dot C, we use the usual definition. So we have A1, C1 plus A2, C2 plus A3, C3, and we want this to be 0. Similarly, this data is equal to 0. We get B1, C1 plus B2, C2 plus B3, C3. We want this to be 0 as well. Now, remember the goal is to find C1, C2, and C3. You can see that this system of equations has a lot of variables. The answer is not going to be unique. It's okay, we just want to come up with one of them. This is how we are going to do it. First, let's get rid of the last term. So you see that here we have A3, C3 already. We want to have B3 right here. Let's multiply the first equation by B3. And for the second equation, I want to have A3 here, but negative, so that later I can just add the equations and the last term will be gone. So I will multiply the second equation by negative A3. So let's go ahead and work that out. This times this, we get A1 B3 C1 plus this times that, A2 B3 C2. This times this, it's going to be cancelled with this later on, so I'm not going to write it down. I will continue though, because I'm going to add the equations. So it will be this times that, which is a minus A3 B1 C1, and then minus A3 B2 C2. This and that will cancel, gone, and then the right hand side will still be 0. Okay, now combine like terms, the ones with C1. This and that I will factor out the C1. So first we get A1 B3 minus A3 B1, and then times C1. And we combine that with this and that, which is A2 B3 minus A3 B2 times C2. That's equal to 0. Now, remember, we just want to come up with C1 and C2 to make this work. This is the coefficient of C1. Imagine C1 is equal to this right here. In the meantime, we just need C to be the opposite of this. And then when we combine them, of course, it will be gone. So right here, we are going to choose C1 to be equal to this coefficient, which is just A2 B3 minus A3 B2. In the meantime, C2 has to be negative of that coefficient. A1 B3 minus A3 B1. Have a look, we got two components already. Now we just need to end up with C3 and we'll be done. Okay, so how do we do it? Let's look at the first equation and isolate C3. So we see that C3 is equal to, I put these two terms to the other side so we get negative, and then divide the A3 to both sides so we get negative 1 over A3. And right here you might be wondering, what if A3 is equal to 0? I am aware of that issue, but we're just trying to work out the formula. Later on you will see that A3 will cancel, so right now a short answer for you guys is that you don't have to worry about that. Anyways, I factored out the negative right here already, so this is going to be A1C1 plus A2C2. So now I just have to plug in this into C1 and then this into C2 and then try to simplify it. So C3 equals negative 1 over A3 times A1 times this, we get A1 A2 B3 minus A1 A3 B2. And then right here, A2 times this, we have a negative, so it's a minus A1 A2 B3, and then negative, negative, so it becomes plus A2 times that, which is A2 A3 B1. Yes. And now have a look. We can actually cancel this out. This is negative A1 A2 B3, and this is positive A1 A2 B3, which is very nice. Moreover, we can reduce out the A3. You see, this A3 can be reduced out with this and also another one. So you can see that C3 is going to be, I'm going to distribute the negative right here as well. So negative and that it becomes positive. We get A1 B2, and then negative times that is minus A2 B1. So here we have it. We have C1, C2, and C3. That's pretty much it. If you want to use this formula to find the cross product, you can go ahead and do that. But this is extremely hard to remember because of all the subscripts, right? However, don't worry, because the determinant of a matrix, it helps us tremendously in this case. So let's have a look. So these are the results that we got from earlier. Now let's take a look at the usual way that we compute the cross product. When we have A cross B, we first set up a 3 by 3 matrix. The first row is the I, J, K unit vectors, and then the second row is these entries, A1, A2, A3, and then the third row, B1, B2, B3. And to compute this determinant, we will do the cofactor expansion across the first row. So starting with this entry, you get rid of this column and you get rid of this row. You look at this 2 by 2 matrix and do the determinant. So you do this times this, A2, B3, and then you subtract this times that, A3, B2. And this is with the I unit vector. And this will give you the first component of C, which is our C1. And that's exactly what we have right here as well. Yay. And then we just continue. But for the next one right here, you have to remember when you do the cofactor expansion, the sign alternates. So it's not plus, but instead we are going to subtract. And then you get rid of this row and this and this column and this column, and then you do this times that, which is A1 B3, and then minus this times that, so minus A3 B1, and that is with the J, and then lastly for this, it's plus. Get rid of this, get rid of that, so you do this times this, which is A1 B2, and then minus A2 B1, and now with the K. And have a look. This right here is our C1, and this right here is precisely our C2, and lastly, this is C3. So, as you can see, it's just so nice that if you do the 3 by 3 determinant, you actually end up exactly what we're looking for earlier as well. That's why we set it like this, and it helps us remember the formula much better.